So today, what's going to happen is we're going to start to focus on what we call the converse theorem. So we're not going to only do them, but basically, in addition to the questions we've been doing so far, we're also going to talk about how do we prove something is a cyclic quad, and how do we prove something is a tangent to a circle. And so just to show you how these work, let's look at this one first. If you have a quadrilateral, any old quadrilateral, and you show that opposite angles add up to 180 or are supplementary, then you know that we can put a circle, no, that's not a very good circle, through those 4 points. And we call that theorem the converse opposite angles cyclic quad. And what that allows us to prove is that something is a cyclic quadrilateral. So that is the first one. The second one is if you have a quadrilateral, and I'm just drawing any random quadrilateral, if the exterior angle is equal to the interior opposite angle, then we also know that we can fit a circle through those 4 points. And that theorem is called converse exterior angle cyclic quad. And so that would be the second one, the second way of doing that. And then the third one is to say, look, if you have a chord and that chord subtends or builds an angle, which is that, and that same chord builds another angle from the same place there, and that's the same, then that butterfly can fit a circle through there. And I'm sure you can guess what that's going to be called. That's going to be called converse angles in same segment. And so those are the 3 ways that we need to watch out for if we want to check whether something's a cyclic quad or not. Obviously, if we visually, we can see a cyclic quad has all 4 points on a circle, but this allows us to check in sort of another way. Give me a thumbs up if those converse theorems look vaguely familiar. So for Teko, I'm not going to go into super detail about what it means, but it basically means the other way around informally. So normally you're given something's a cyclic quad, therefore you know it's true. In this case, you check, is this thing true, to know that it's a cyclic quad. So the technical definition, is like if P implies Q, then the converse is Q implies P. But there's not time to go into too much detail about that. Okay. So that's the one thing we need to bear in mind today. The other thing to bear in mind is how to prove something is a tangent. And so I'll probably talk more about this on Wednesday, but basically, if the angle between the line and the radius is 90, then that line is a tangent. And we just call that theorem, what do you think it's going to be called? If you look at what we've done so far, what do you think the theorem is going to be called that shows that the line is a tangent? It's going to be converse what? What's the yellow one going to be? Put your answer in the chat or let me know. So it's going to be converse tan radius theorem. Yes, converse tan radius. And we're just checking to see if there's a line and there is a radius. Okay, so let's say there's a circle. Okay, that doesn't actually look very good. Let me try and do that a bit better. So if you've got a line and then you've got a circle and the line between, or the angle between the line and the radius is 90, then you know that line is a tangent. And then if the angle between the line and chord equals the angle subtended by the chord in the opposite circle segment. Oh my goodness, what a mouthful. What's the easy way to say this? Converse what? It's just going to be converse tan chord theorem. Okay, now for all that mouthful, okay, all we're doing is basically checking the converse tan chord theorem. And we'll see that when we can see that in an actual question, it will make a bit more sense. But in the background today, these 5 converse theorems are one of the things that I want us to start to be aware of. Give me a thumbs up if you understand that converses are used to prove something is a cyclic quad or tangent. You could also, there's one other converse that is useful. If a line segment subtends, let me just, since we're doing converses, let me do it at the same time. If you've got a line segment and that line segment subtends an angle at 90. So we've got a line segment over here and it subtends an angle at 90. Okay. What do we know about that line segment? What do we know about? So if AB subtends an angle of 90, what is special about AB? Yeah, AB is a diameter. And what is that going to be converse? Converse what? So converse angles in semicircle. And so we can use the converses here to prove something is a diameter. So I often find with my students, if they get this idea that, okay, we start with the questions where we find angles. After we find equivalent angles or angles with a value, we start to look for these converse questions where we have to prove things. And I like to build up their understanding. And this is the second layer of understanding. Okay, but we need to practice. So let's get to questions. Before we can get to those questions, let's just start with a warm-up. And so here is the warm-up for today. I want you to find me the values of A, B, C, X, and Y. And you do them in whatever order makes the most sense. See if you can find A, B, and I'm going to get some water and turn the lights on. So A is equal to 10 radii is probably the easiest one to spot straight away. But be careful. You can't actually say that Y is 90 yet. And you can't get B. You don't know what B is either because you don't know that Y is 90 yet. It looks like it, but you haven't proved it. So what is the next value that you can find after finding A? So Trishan, the problem is it looks like 90, but you don't know that yet. You actually have to find, okay, so the problem, Flamelo, is you don't know enough information yet. I want to suggest that finding X is the first thing you have to do, because that's the only thing you can find straight away. So what is X going to be? Now, what you'll notice is that X is not too difficult once I point it out, right? So X is 35 degrees. And the reason is either radii, or you can say angles opposite equal sides. So that and that side are both opposite at 10. So we would say angles opposite equal sides. Okay, now once we know what X is, what is the next step going to be? Yes, Obongwe. Yes, you've got it. You've got it. So Beverly, you wouldn't be able to find Y until you found X, because you don't actually know what Y is for sure. There's not enough information. So you can work out y after you've got these two, because you go 180 minus 55 minus 35. And that's sum of angles in a triangle. And so now you know that this is 90. Now, this is good news, because what can we work out next? We can work out, well, I think we can work out B next, because now we have the 90 degrees, which means that B, because this is a line from the center perpendicular to chord, the B must be 4. And the reason is just line from center perpendicular to chord. And we know that it's perpendicular because we showed that y was 90. So we know that this thing over here is going to be 4. Now, the last thing we need to find is the little c over here. You need to figure out what that blue bit is there. So yeah, so for Techo, you can't just say y is 4 without finding y. You can't just see it's perpendicular, because you don't know if it's maybe 89 degrees, right? You don't know. It looks like 90, but that's an assumption. Okay. How would I work out C, and what theorem do I need to use? Oratile, you are smashing it. Yes. You know this is a 90-degree angle. You know that you have 10. You know you have 4. And so if I take my working out down here, I can say that 10 squared is equal to 4 squared plus c squared by Pythag. And then if I do some rearranging, 10 squared minus 4 squared equals c squared. And then basically I just need to go 100 minus 16 equals c, which should give me about 9.17. So that would be 9.17. So, I mean, that wasn't actually easy. It was a combo of things, and you had to sort of use your knowledge of circles to get there. So it was a nice question to get going today. Give me a thumbs up if you followed everything there. Give me a thumbs down if you're feeling a bit like, whoa, 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 whoa. Okay. Because remember, I can't always see you all the time. So the thumbs are what I use to just get a feel for if I'm moving too fast or too slow. Okay. So it's important you vote honestly to help me get a sense of what's going on. Okay, now, what I want to do next is I want you to find me X, Y, and Z in this question. And for those who are feeling a bit like the first one was a bit hard, remember that you can watch that first bit again a second time, and it will be a bit clearer because the recording will come out this evening. So find me X, Y, and Z. Put your answers in the chat. So I see lots of 80s and I see lots of couple of different things. If we look at this shape, I'm going to focus on the arc XY, sorry, not XY, VY. And I'm going to ask myself, if that makes an angle there and it makes another angle up here, what is the relationship between here and here? That's the big first question. I think that this is an example of the angle at the center and the angle at the circumference. Yes, and it's easy to fall into the trap thinking it's angles in the same segment. So this X should be 40 And it should be angle at center equals twice angle at circumference. Because look at this shape here. Here's my, let's see if I can get it here. So there is my arc, call it the arc VY, and it makes an angle at the center, but it also makes an angle at the circumference. They're not angles in the same segment for Deco because this point O is not on the circumference. It needs to be on the circumference in order for the butterfly to work properly. And Tato, don't worry, you're not alone. It catches so many people. And if I hadn't done this a lot of times, it would catch me too. The key thing is that when you have the butterfly, let me show you here. Here's your chord or your arc. The angle goes up there, and then the angle here goes up there. And you'll notice that these two are the ones that are in relationship, or let me make it different, those two. Notice how the points are on the circumference of the circle. Yes. Okay, now, what about Y? I think Y was a bit easier. Y is just going to be 80 alternate angles. And what are my parallel lines? It's going to be OV parallel to XY. So we know that this is 80 and we know this is 40. Now, what about the Z? What do we think the Z is going to be? That's this little one hiding down here. So the problem, I've noticed tan chord or retido, but the problem is I don't see a tangent. If I had a tangent would just touch it in one place only. But the problem is this is touching it in two. This is called a secant actually, because it touches it in two places. So what ideas do we have for finding Z? I'll give you one little sneaky hint. See if my yellow coloring in can help you. Remember, I choose these questions to teach you interesting things as we go. Ooh, yes, Kat, you've got my message. Okay, so now how can we use the fact that we have a cyclic quad to help us get Z? You are well done. So there's two ways you could do this. The one way is to say opposite angles in a cyclic quad, that must be 140, therefore Z is 40. Or you can go straight and say, well, that's interior opposite. So these two are in relationship, exterior angle of a cyclic quad. So we would say Z is 40, exterior angle cyclic quad. But there's nothing wrong with saying, look, that's 40, that's 140, and that's opposite angle cyclic quad, and then saying angles on a straight line. That will also get us to the same place. Okay. Would you still get a mark if your reasons are wrong? You would still get mark, yeah, if it was 2 marks. If your reason was wrong, you would only get, say, 1 out of 2 for that one there. But if you gave another way of doing it that was correct, you'd still get full marks. Yeah. And Paul, it is, and the thing is, if you do enough questions, the sneakiness goes down a bit. Emmanuel, what is your question? Can we unmute Emmanuel for his question? Or yeah. Or her question? Yeah. We're coming to you now, Emmanuel. Okay, if we could just unmute Emmanuel there. Let's have a look. Okay, can you hear me, Emmanuel?
Hi, sir.
Hey, what can I do for you?
All right, sir. I want to ask, sir, can't we use the quad of OVYZ to find
OVYZ, yeah.
the angle Z, sir?
Okay, here's the problem. The way you would have to do it, you could, but you'd have to work out what that angle over there is. Can you see that big blue thing there?
Yes,
What's
sir.
that big blue one going to be?
It's gonna be 100 if I'm right.
Not quite, because remember,
Oh,
it's
it angles around the point. So
yeah,
it's gonna be 360 minus 80, which
perfect,
is
which is
280.
280.
Yes, sir.
And then you don't use the angle in a cyclic quad. What you say is that's the angle at the center, and the angle at the circumference is going to be half of the angle at the center. So can you see how it's
Oh,
half of that?
yes,
And
sir, I
so
can see it.
then you could say, okay, that's 140 and therefore that's 40. But it's a great question. So actually there was another way of doing it that I didn't even think of,
All right,
just to
sir.
show you how it all works together. Yeah.
Thank you, sir.
No, cool. Good question. All right. Let's have a look at, well, let's go to a question that sort of shows you where the cyclic quad thing is coming from. So what you'll notice in this question is you have part one, and part one is find me angles equal to whatever, and you have to interpret the drawing. Part two says, tell me if this one is a cyclic quad. Now, I want you, we're gonna go for 5 minutes more, then take our break. Can you guys try and do this first part here for me? Can you try and do that? And then we'll take a break when you've done that, and we'll come back after the break and start with the 2.2 part. So pop your answers in the chat. I'll get some more water. Okay, where's T1? So T1 goes to the midpoint of a chord. So it must be 90, and that would be line from center to midpoint chord. Let me make this a bit bigger so it's easier to write. Line from center to midpoint of chord. So this over here must be 90. That must be 90. Now, O2 is here, but I can see that sometimes they call this the arrowhead. So the chord PM will subtend that angle at the center, and it will subtend that angle at the circumference. And so this one will be double that. And this will be 100. And we'll go angle at center equals twice angle at circumference. So this must be 100. Now the question is, what is S? There's actually two ways that I can see we can do S, but I suspect most of you are going to say S is 50 because you can see that angles in the same segment. And you can kind of see the butterfly there. Or you could say angle at the center is 100. What's half of 100? It's going to be 50. And this would just be the angle at the circumference, because you're still using this chord PM. So you could have done it that way as well. So we've got T1, we've got O2, we've got S. Now we've got to find what P1 is. I'll give you some more time. Ooh, Amakle, you are good. You are good. So you absolutely use radii. You use something else as well. What's the other reason you use to help you, Amakle? But you're perfectly correct. I just want to know what's the other bit of information we use. So Amakle has spotted that this length over here must be equal to that length because of radii. Or, we could say OP equals OM radii. Now that helps us. Yes. And the reason we can divide by 2, Andile, so Andile has said, look, every triangle's got to be 180. We can take away 100 and divide by 2, and we get the answer of 40. Now, the answer is 40, but you've used the 2 reasons. You've used radii, and you've used sum of angles in a triangle. And so those 2 ideas together tell me that this is 40 and this is 40. Okay, now, before we take our break, we're going to attempt 2.2 because we've been doing well here. It says here, is TOPM a cyclic quad? So first, all I'm going to do is make sure my brain knows where to look. So I go to TOPM. Is TOPM a cyclic quad? And why is it a cyclic quad or not a cyclic quad? Give me your information in the thing. So everyone is saying it's not a cyclic quad, and the reason it's not a cyclic quad is opposite angles are not supplementary, or you could say they don't add up to 180. So if you look at P1 plus T1, that would be 40 plus 90, which is 130, which is not equal to 180. So we know that the blue quad is not a cyclic quad. We could not fit a circle through this because the opposite angles are not supplementary. Oh, you're right. Or what we could say is we could say the exterior angle. So look at this angle here. Here's the exterior angle. It's not equal. So T2 is not equal to P1 because T2 was 90 and P1 was 40. And so that would be the other way of showing it, is to show that these 2 are not equal. Give me a thumbs up if you followed that argument about showing it's not a cyclic quad. Give me a thumbs down if I lost you. Flumelo, let's go to you. We'll unmute you. Flumelo, can you hear me?
Hello, sir. How are you?
Very good. How can I help?
Sir, can we use the reason that one of the points is not, actually both of the points are not touching a circumference?
Okay, here's the problem, Romero. It doesn't have to be the only circle in the world is not S, like, if I look at, we're asking, can we fit any circle through this? Just because it doesn't fit on this circle doesn't mean there couldn't also be another circle that maybe fits through it. So does that make sense? Like that, we're not checking whether or not it's on the circle we've drawn. We're checking or not whether it's possible to draw any circle. And if it was supplementary, then we could fit a circle through those 4 points. And because we know that it's not, the opposite angles are not supplementary, it's not possible to get all 4 points on a circle. So it's a little bit different to just saying, we can't draw every possible circle in the world on the drawing. Okay. All right, we're going to take a break. So I want everybody on their feet, and we're just going to take a quick break because we've got, we're making good progress. but turn your cameras on. And let's just start by standing up nice and tall. And let's take some deep breaths. I'll breathe in. And breathe out. And then breathe in. And breathe out. And one more breath. Okay. Let's just do a little bit of a shake. Shake the arms. Shake the legs. Get some circulation moving in your body. So hopefully the oxygen is flowing, the blood is flowing. And then just do a little bit of rotating. So your hips loosen up a little bit. Don't go too far initially. Just let yourself relax. And then as you relax, you'll find that you go so much further. And then you know you are relaxing. And don't push yourself unnecessarily far either. You're just trying to loosen up. Okay, let's do the shoulders. Stretch that, then stretch the other side. And then let's do some triceps. So we'll do that. That feels good. My tricep always feels tight. And then let's do the other side. Oh, and then let's just shake it out one more time. And then we're going to do some air skipping just to get blood pumping. And we'll do 20 and starting in 3, 2, 1. Let's go. And there we go. All right. I hope that your body feels a little bit looser. And here is the maths 24. Tell me if you can do any of those 3 there. Yeah, I know it's good for me and it's good for the students, so I make sure I always exercise. Especially, like I've read enough studies to know, even though like our body isn't made to sit for more than half an hour, so that's why it doesn't really matter to me how, as long as you do something, I know that it helps your learning. Okay, who can import? What have you got here? You've got 7 minus 5 plus 1, which gives us 3, and then 3 times the 8 gives us 24. So red is done. Who can do the blue or the yellow? So Tato, what happens is your brain just doesn't process as efficiently. So in fact, it's actually even more like 15 to 20 minutes, and then your concentration gets to fall off. Whereas if you get up and do something, it almost resets your attention span. And so that's why I do it, and I make my students do it in class, because it's like we all want to learn as well as we can in the limited time we have. So why not stop for 2 minutes and just, take care of your body so that it learns well. Yeah. Okay, Kitso, let's have a look. So Kitso has said 8 times, oh, that's sneaky, 4 minus 5 minus 1. Oh, the answers are flying in now. 5 minus 1, 4. I don't know if I get your way there, Kitso. Here we get 5 times 3 from K-Lead, and then plus 8 plus 1, which gets 24. So that is correct. And then Bongwe has also given us a way of doing the yellow. 5 minus 3 is 2. 2 plus 1 is 3. 3 times 8. Perfect. And then Emmanuel has said 8 minus 4 gives us 4. and then 4 times 5 plus 1. So we get 4 times 6 is 24. Well done. Well done, everyone. Ooh, okay. Cool. All right, we've had our break. Let's get back to the lesson. So in the next part of the lesson, we are going to start with another exam type question. And we are going to start with this. In the diagram, PSRM, there's an S sitting up here. Apologies, it's gone a bit missing. So we have our drawing up here, and there's an S. And to start with, you need to find me 3 other angles that are equal to X. We are given that MOS is 2X. So I want you guys to try and find me 3 other angles equal to X if you know the green one is 2X. Off we go. So M1 equals X by radii. I agree that there are radii here, but I don't know why, if radii would make that X. So Machli, you're on the right track, and I agree there are radii here, but I think it just makes, oh wait, maybe you make 180 minus 2X. I suppose you could do it like that. So you could say M1 is 180 minus 2X divided by 2. But then you're going to get 90 minus X, which isn't really what you want X by itself. So it's not a bad idea, but equal sides, equal angles. Ooh, okay. All right. There's a couple of ways we could do this. I'm going to give you the hint that this chord is quite important. So that chord over there is quite important. And if I take that chord and I make an angle at the center, let's start here. There is my angle at the center. Now that same blue chord can also make an angle at the circumference. So what do we think is the first angle equal to X? And what is the reason for that? So I think that P1 is equal to X, and the reason is angle at center equals twice angle at circumference, because this one is the one at the center and this is the one at the circumference, and the blue is just the chord that is subtending the angle. Now the shape is a bit weird because you don't see that often where it lies directly on top. Okay, what about R1? Tato, you make a good case. Is R1 going to be X, or is it going to be something else? What do you think? So R1 is the opposite angle of a cyclic quad, you're right, but is it R1 we want, or what in the neighborhood would be more useful if the goal is to find other angles equal to X? Aha, yes, R2 is what we want. And what's going to be the reason that R2 equals X? Exterior angle, cyclic quad. Yes. Perfect. Now, if we know, we need one more. We need one more value of X. For Tejo, the reason R1 isn't X is that R1 would actually be 180 minus X because it's opposite angles in a cyclic quad. Okay, M3, could it be M3? Well, M3 is actually going to go with this one over here. So it can't be M3, but I'll give you a hint. I'll give you a hint. Oh, tan chord. Not a bad guess, Zayan, but the problem is there's no tangents. I'll give you this hint. What is OP and what is OS? What is OP and what is OS? Okay, now both of those are radii, which means that this must be equal to this. So what's the next angle equal to X? Khopotso, absolutely agree. Trishan, on the money there. Yes, so we say S1 is equal to X, and we can say either radii or angles opposite equal sides. Yeah. All right, so we have done that. The next thing I want you to try and do is I want you to try and express S2 in terms of X. Now, first of all, we have to find where S2 is. S2 is sitting over here. Zayan, can we unmute Zayan? And then I'll come to the lady's question in a second. So let's have a look here. Zayan, can you hear me? Zayan, can you hear me? Hey.
Hello, sir.
Hey, what can I do for you? What's your question?
So I wanted to inquire about P1 and R1.
And
Since
R1.
Yes, sir. Since they're subtended by the same chord SM, wouldn't they be equal?
Okay, let's have a look. So SM is the same chord. The problem is that they wouldn't because they're on different sides. So let me give you an example. If X was 50, then R1 would be 130 because there is a cyclic quad which is going around the outside here. Can you see it there? So the chords, just because the chord on the one side would not be the same as the chord on this side. If I had a shape going from there and it made it like a butterfly like that, then this angle down here would also be, oh, sorry guys. That would be 50 and that would be 50. But that's on the same side, whereas this is on the other side. Okay. So now, does that help, Zayan?
Yes, sir.
Cool. Good question. Thank you.
Thank you.
See, guys, this is why asking questions is so important, because it helps a lot of students, not just you. And it also brings awareness. Okay, now S2, the key thing is to realize that that angle and that angle over there they're also made up of radii. So S2 is going to be 180 minus 2x divided by 2. And the reasons, it doesn't actually, well, the reason would be radii and sum of angles in triangle. And so S2 would just be 90 minus x, because 180 divided by 2 and minus 2x divided by 2. So Naledi's question, for something to be a tangent, does the question have to say it is a tangent? Okay, so Naledi, in order to use the tangent theorems, you have to know there's a tangent involved. Okay, in this case, there is no mention of a tangent, right? And visually, I can't see a tangent. A tangent would look like that, or a tangent could look like that. However, if the question says prove something is a tangent, that is a case of trying to prove that a line is a tangent, and you would use the converse theorems. But if you want to use the theorems that deal with tangents, it does need to visually show or tell you there's a tangent involved. So I hope that helps a bit, Naledi. Impor's question is, so can't we use angles in a semicircle? We could. So Impor has made a very good deduction that this angle up here is 90 because of angles in a semicircle. You know that S1 is X. Therefore, this little bit over here must just be 90 minus X. And so Impor, there is absolutely no problem. In fact, that's as correct, if not more correct. So great spot there. Okay, last bit. Is SRMO is a cyclic quadrilateral, true or false? So I want you guys to think about this. Is SRMO a cyclic quad or not? I will draw it in a second, but for the moment, I just want you guys to think about that. And I'll make sure I make this was 90 minus X. Now, where is SRMO? Maybe I should get rid of the green stuff. SR, so SRMO. SRMO. So it says true or false, explain your answer. So what are we looking to find, everyone, to make sure that whether or not it's a cyclic quad or not? So we know, what would the exterior angle? I think a lot of you are looking at this exterior angle over here, hey? And you know that's 50. Or do we know that's 50? Where did we work that out? So just because it's not on circumference, it could be possible to fit a circle through the pink outline. So let's have a quick look here. We're running out of time, so I'm gonna bring up the answer. But what I was thinking is you need to either notice that this angle over here is equal to that one there, or you need to show that this angle over here and this angle over here add up to 180. Now, what would be very helpful is if you knew what X was. Would you agree with that? So, oh, of course, yes. Well spotted, Emmanuel. Emmanuel said, don't look at my big red dot. Look at this lonely X hanging out over here. And what is R2's relationship with 2X over here? Isn't that the interior opposite and that's the exterior? So what we would say is that, let me write this down for you. We would say that R2 does not equal to SOM because X does not equal 2X. Therefore, SRMO is not a cyclic quad because exterior angle doesn't equal. You wouldn't have to write that much. You just have to show that main idea. And if you want to see the official working out, here it is. Let me show you. I don't know if that helps a little bit. You can see that there. Now, give me a thumbs up if you could follow that thinking, and give me a thumbs down if you didn't follow it. I just want to end today by giving you a link to some class notes on circles. Some students were asking about extra notes just to give you some guidance on this topic. And I've got some notes from the Western Cape Education Department that are freely available, and I can just give them to you if you would like access to them. And so I'm just going to put the link to those in the chat. just let me, oh wait, I sent it to an individual student. Let me change it to everyone. So if you would like a set of notes, now the reason I don't give out notes often in the lessons is it's a little bit too much detail all at once, but just download those notes for a set of kind of summary notes on the topic. And then Kia, if you could just send out the poll now so that students can, vote on how they found the pace of the lesson today. Oh, you don't have access to it. Sorry. Okay. Well, polls, pacing poll, launch. Okay, so you should get the poll there, everyone. And then once you've done the poll and you've got the link to the extra notes, then I think we are all done for today. And on Wednesday, we will continue with proving, like kind of mixing in these other types of questions about proving something's a cyclic quad, or proving something's a tangent, or proving something's a diameter. And we'll just keep building our knowledge of the different types of questions. Cheers, Oratile. Hope you have a good. So where can I find exam questions? So Trishan, they are going to give some exam questions at the boot camp. But what I'll do is in the next lesson, maybe I can bring some other circle geometry questions from past exams. Also remember that there are quizzes on circle geometry. The weekly quizzes have questions from past exams, but I can bring you one or two on circles if you'd like in the next lesson, just to top up your understanding a bit more, if you're keen to do a bit more practice. Monica, let's go to you. I see your hand is up. What is your question? Can you unmute, Monica?
Yes, sir.
Hey, how can I help?
Sir, I have a question. It's not regarding circle geometry, but finance.
Finance. Okay.
Yes.
Right now, there's not going to be time to go into finance right now, but can I recommend you go to the Watobe website? I did 6 lessons on finance, and there are 3 very nice quizzes. And so can I suggest you look at that?